Hello, everyone. Welcome to PyData Global. This is the last session for the day, so thank you for joining us. We are excited to have you join us. Feel free to use the chat to connect with fellow attendees and share your thoughts during the session. If you have any questions, please post them in the Q&A tab, and we will address them throughout the session as appropriate. But now it's my pleasure to introduce Daniel Chen. He will be presenting his talk, Tips for Leveling Up Your Shiny for Python Applications. Daniel is a lecturer at the University of British Columbia in Vancouver and a data science educator at POSIT. Let's give a warm welcome to Daniel.
All right, welcome everyone. So I am here to talk to you about Shiny for Python, but also how to improve your Python code. So we're here at PyData, and we are all probably listening to all of these talks and attending this conference because we are working in a data science field. And one of the most important things that we as data scientists need to do is to communicate our results. And hopefully in this talk, I'll show you about a new tool, Shiny for Python, but then also some tooling agnostic tips on how to just make your data science code better. So hello, everyone. Like Jim has said, I'm Daniel. I am currently a lecturer at the University of British Columbia. I help teach some courses in the Master's of Data Science program there. And I also am a data science educator and through developer relations at POSIT. So first, I've talked a little bit or mentioned Shiny for Python. So for the people who have never heard of this tool before, what is Shiny? Well, Shiny is a interactive web framework and primarily used for dashboards and data-driven applications. And one of the features of this tool that make it really unique and pretty cool is how it can automatically handle inputs and outputs. And you'll hear that being referred to as reactivity in Shiny World. And there's a website to Shiny for Python, and if you want, you can try it live through WebAssembly. Nothing needs to be installed, and you can see some of the examples and things there. I'm not the first person to talk about Shiny for Python. I'm also not the first person to talk about Shiny for Python at the PyData conferences. And so there are a couple of talks from my colleagues. Gordon, Tracy, and Joe have all talked in various PyData conferences about Shiny for Python. But I hope to add to that set of talks by talking about how we can improve our actual code. So for those who have never heard of Shiny for Python before, I'll sort of set the stage about what really makes it special. Like I said before, it's about reactivity. And so what does that mean? It means that outputs automatically update when their inputs change. So if you've worked in any type of web framework and anything that works asynchronously, typically you have to do the accounting of when something updates, you have to go and write typically like a callback on everything else that needs to retrigger again. You don't need to do that with reactive programming, and Shiny isn't the only tool in the web framework world that uses reactivity, but it has that is sort of the mindset you need to think about when programming Shiny. And because of its reactivity and not needing to write things like callbacks and handle that accounting on your own, it makes it really intuitive and easy to build new tools out of. And at the end of the day, it is also an interactive tool for data analysis. So what is reactivity and this automatic nature? And so I'll talk to you about how some of this automaticness happens. So here is a set of graph objects about all of the things that might happen as you're doing a piece of analysis. And so here's the initial state. The rectangles on the top are going to be the inputs like data or sliders or checkboxes, stuff like that. The hexagons represent reactive expressions, so things that I need to calculate or Shiny needs to calculate to do like an intermediate step. And then the circles at the bottom represent some type of final output. So in here, you'll see model scores from like a machine learning model and maybe like an API response. Those will be our outputs. So what happens when somebody asks for a model score? Well, what ends up happening is we build this graph pretty much automatically, and it has to do with the way you're programming in Shiny. It inherently creates these linkages together. And so it finds that, oh, I need this intermediate filtered data set to calculate the model score. But the filter data set is an intermediate calculation. It's a reactive calculation. So where does that come from? Well, it finds out that there's an input for the account. And it also finds out that, oh, I need my sample data um, for that intermediate calculation as well. And then because sample itself is a reactive calculation, it goes up the tree again and finds those inputs. And all of those things combined, it will give you your model score. Likewise, if the API response is requested, well, actually the filtered value was already calculated. And so it can just give you that response right away. Nothing was out of date. And so the API response will be pretty quick after it finds the model score. But let's say what happens if you go and change the account value. So this is analogous to, maybe I uploaded a different data set. Maybe it's a drop down and you're swapping the account. Well, what it finds is everything downstream of the account gets invalidated. And then you go through the process of recalculating everything back. And so that's what makes working with Shiny sort of magical. Like you don't have to write callbacks. You are also guaranteed that when you are requesting something, it's always the latest version of everything that fed into it. And you don't have to worry about, oh, if you had missed a callback, not only is the result outdated, it's actually just wrong. And so Shiny has a mechanism through reactivity to prevent that. And so another example is what happens if something upstream changes, like the sample size? Well, it goes and invalidates everything downstream of it. And then we go through the process of that I showed you in the very beginning to calculate everything. So that's how Shiny works. It's a really cool tool. And if you've tried to make dashboards before and want to test this out, or you're sick of writing callbacks, I would say just give that a try. But that's just about Shiny. I'm here to actually give you tips about writing better Shiny apps and also really just tips of writing better Python code. And so here's a example application. It's a very minimal example. And the problem I was trying to solve was, I was doing this earlier, was I wanted to provide a way for people to explore a data set. So here's an example tips data set. But I wanted them to explore it in such a way where if the users are using filters and ways to explore and slice and dice the data, that they don't accidentally just return an empty data frame. So for example, if I look for lunch values and then I can hit Thursday, you'll notice that like I got no data back. And that's sort of, if that's a feature that you expect and want to use, you can totally do it. But I wanted this to be done in such a way where the day filter will filter itself down depending on all of the other sliders. And so this required a new way, or like sort of my own custom implementation of how these inputs work. And I want to spend today talking to you about my what I've learned trying to do my own custom implementation of these input components. And so the problem was I want users to explore a data set, but I really wanted the filters themselves to react to the inputs such that the user doesn't accidentally give themselves a empty data set. And so I got to learn from the best. I got to learn from Joe Chang. So he is the current CTO of Posit, but also the original author of Shiny. And so I got to work with him for a little bit and work on this adaptive filters project. And so I'm here to give you all a few tips on what I actually learned through the process. So tip number one, keep your variable types consistent. So this was something that I code right away and wasn't really thinking about it when I was going through a code review and realized that, yes, when I am trying to put code into production, this is something I really need to think about in the second pass of cleaning up my work. So for example, I wanted each filter to operate on a data, so to get the observations that matched. And then in order for this adaptive filters project to work, I needed the intersection of all the filtered values. So it's a fancy way of subsetting the data set because I really wanted the data frame index to be used as the identifier. And so there were a couple of steps: get the data frame, get the index, convert the index to a set, because for me, intersection was a Python set. And that's sort of what I sort of pigeonholed and looked into in a lot of detail. And then once I have a set, I can do the intersection call. And then I also realized that in order to filter off of values, Pandas doesn't know how to filter off of a set. So I return a list of values. And so here's the example code. I have the important parts highlighted. You see the data frame, the getting the index, converting it into a set, doing the intersection. And then the last line, the return was, oh, now I have to like actually return a list object. And so if you're thinking about Python functions, as long as the contract between the user is here's what I expect as input and here's what you get as output, as long as you tell the user that, you can pretty much do whatever you want in between. At least that's what I thought. But if you're thinking about your own code maintenance, or you're actually trying to share this code with other people and other people are going to look at this, there is a lot of data type conversions that I've done just in this really simple block of code. And so a little bit of digging through the documentation, I found that Pandas index objects themselves also have an intersection method. And so no need to convert to a set, no need to deal with returning a list, because now Pandas doesn't have to deal with the set. And so you can see like literally the same amount of code in lines of code, but because I'm not constantly flip-flopping between the data type, it's a lot easier to keep track of what's going on in your code. I also aren't just lying to other people and to myself about like, here's a variable called IDX for the index, but no, it's really a set, and no, it's really a list at the end, right? So this really does help with code readability, maintainability, and other people who are trying to just think about what's happening with your logic, not having to do that mental gymnastics of thinking about what the actual data type is. It's really important. So what did I learn? Don't reuse the same variable names if you're going to be doing something like that where you're changing the data type. And if you end up doing something like that, like really look into the documentation and just see if there's a better way. Like Raymond Heidegger always says, like there probably is a better way. And again, functions, as you're learning to write functions, yes, the contract between input and output is really important, but as you're trying to think about writing better code, especially as data scientists, when we're not trained as software engineers, this is something that you want to think about as well. So tip number 2, use Python type hints. So this is sort of a newer feature of Python and something I'm learning every time I'm coding in Python now. But essentially what this allows you to do is you get to put a little bit of information and give Python a hint about, here's the actual data type that is being stored in this variable. And so what type hints allow you to do, or force you to do, is to be really intentional with the variables you're creating and the variables you're using. And you're almost always getting a hint at what the actual data type is, and it helps offload any of the cognitive load that you might experience as you're trying to read through a brand new code base or maintain an existing one. Something else that you can do with type hints, sometimes it's, an error happens during the import call, and I just need to straight up ignore it. So that's another thing that you can also do with type hints. In my particular project, I was using Pywrite. MyPy is another tool that you hear a lot in Python land about using Python type hints. And then sort of the throw the kitchen sink at the problem and just obliterate everything. If you also end up with type hinting issues, you can always cast the variable using the cast function from the typing module. And what this will do is tell the type checker, or tell the type hinting or Pywrite, that no, this is the actual information that's stored in here, and it will be able to pick up on that. You just have to be a little bit careful, because you are telling the type checker this is exactly what it is and I know best. And if you run into a bug or an error, you might run into if you specify this incorrectly, you might run into a really hard time debugging your code. And so what I learned about type checking was type checks actually really help with documentation on its own. You can figure out like, oh, it's supposed to be an index, and that's what I'm working with. Helps parse out bits and pieces of a function or the code base a lot easier, just because you always know what's being stored in something. In my particular project, there was a really complicated and gnarly data object that I created. And so it was really nice to know like, oh, this is what's actually here and not like something else. It helps with code readability. You do have to get used to it. It is a lot more characters on the screen. But once you get used to knowing how to read the type hint information or really ignore the type hint information, you should be able to process your code just like before. But it does take time. It enables tools to help check errors because sometimes you're like, I expect it to be an int and now I'm doing non-integer things, or string and doing non-string things. The type checker will actually hint and throw an error right away, and you don't have to wait for your code to fail in order to pick that up. It helps with keeping data structures and assumptions in your head, just because you're always hinted at what's going on and what's being contained inside. But like I said, I'm still very new to using type hints, and so I don't really know how to fix every single type hint problem, but it is something to think about if you haven't been using it already. The third thing is when you should know to use Shiny modules. So a module in Python is sort of a .py file that you can import. In that sense, it's similar to a Shiny module, but a Shiny module is similar to a module like a Python module, but it has all the Shiny components in it, meaning that it is a module of the user interface and the server functions that you need, which means that it also has all of those parts that make the reactive graph, that's all contained in a module. So that's what makes it a Shiny module, not just a regular Python module, in that what's contained in here also has all of that reactivity, how things are related and connected to one another is inside a Shiny module. And so how do you know you need to start looking into Shiny modules? So there's a couple of code smells that hint at when you might want to start looking into this. The first one is calling the same component or creating multiple that you're creating multiple times. That's really similar to using a function. And so whenever you're repurposing something, if you find yourself copying pasting big swaths of code, you should probably refactor, turn into a function, turn into a module, turn into a Shiny module. There is creating a list ID of values and iterating over them. So anytime you start creating a list of something, you're like, oh, I need to just do something across all of these. That might be a code smell around refactoring your code into a Shiny module. If you end up tracking two lists, and the ID and for some other component, that's another hint that you might need to be using a Shiny module. So for example, maybe you're trying to track the ID of the component, but also the label, like what's being shown in the user interface. And you need to always keep track of those two things at the same time. Probably wrap that all up in a Shiny module. And if you have to iterate across multiple things, or especially if you find yourself keeping track of IDs and labels and other parts in that reactive graph, and you find yourself using the zip function, that's also another good time that you might need to be using a module. So there's a lot more information about modules at the bottom of this slide, but um, just know that, yes, it is a more complicated task, but if you find yourself overwhelmed with the amount of Python or Shiny code you have, this is something that you might want to look into. And so for an example of that is, here is bit of code that I actually worked with. And you can see here that I really just need the column name, this middle bit of information, and I can calculate everything else. So this is why I ended up creating a Shiny module, moving things into a Shiny module, also because you see me use the zip function. And so that got refactored into a module in that sense. And if you have really complicated and interweaved behaviors. For example, I had all of this logic around adaptive filters. That's another good use case of creating a Shiny module because all of that logic is outside of your main program. And so if you have a more complicated application, for example, you're using my package of adaptive filters, but also doing other reactive calculations, you can very easily end up in a multi-hundreds of line file. And so that's just a little bit clunky to work with at times. And so this other problem that can arise when you have, all of these things related to one another is like, it's called coupling. So when you're working with Shiny and you have to work with changing the UI, like what gets displayed on the screen, what the input component gets made, and how the calculation is being made with those inputs and outputs. And anytime a new user needs to add something new to this application, and they have to add these things in all 3 or 4 of these locations, that coupling is another sign that you might want to make a module, because all of the things that need to stay together are traveling together, and they're not actually quote unquote far apart from each other, like literally lines apart from each other in the code base or files apart in the code base. So if you find yourself, oh, every time I need to add a new feature and I have to remember to change it here, 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 and there, that is called coupling. And if you have a coupling problem, think about modules, because you can at least contain all of the here's into one file or one location. The other thing, make your Shiny app testable. So testing is really important. You typically hear it when you're writing packages, but you can also test your data, and you can also now test your dashboards as well. So testing is really just have the computer make the checks that you will probably be doing visually, except now you're doing those visual checks through code. And so PyTest is one example of writing tests, and this works for non-reactive calculations. Here's some input, here's an expected output. You kind of just deal with it with an assert statement, and PyTest, whenever the assert fails, the test will fail. With Shiny, because it's now a web interface, you need to be able to essentially mimic web clicks. And so Pyrite is sort of a more modern version of simulating a browser and web clicks. And Shiny does provide a way to that wraps around Pyrite. So it also works with testing your Shiny apps. And so you can see here, we have the Shiny Pyrite module, and there's the actual base Pyrite module, and Shiny does come with a give me an application so I can load it up, and then you can go to the application, pretend to look at a particular input, click and change that input, and then do a check to see what the value is. So you can mimic user behaviors with Pyrite, and it's much better than using a tool like Selenium if that's what you've done before. So testing is always great. Use Pyrite. It's a more modern version than Selenium, and Shiny does come with its own tools to make coding against Pyrite easier. And the last tip I want to give you is think about the developer experience, especially if you have a interactive tool that other people are expected to interact with. And so the problem I had after writing all of this code base and getting adaptive filters to work was, well, sometimes we need to expose different parts to the user to make their own customization. So how do we expose it, and what do we expose? So here's an example of our first attempt of, hey, we want to give the user the ability to change like the label, the input type of a particular component of this adaptive filter component. And so one way was like, okay, you can use a partial, and you can import partials from functools, which comes with base Python. And then you can sort of like write your code like that. And this looks okay until you realize that like, what is this partial thing? It's another, thing that people have to learn about. If you're a data scientist, I don't know if you've ever used a partial before. It's very functional programming-esque. But, something else you have to learn, and that adds a little bit of friction. The other thing is, well, you can use a lambda, and then you end up with a situation where like, okay, you have a lambda that's typically used for like one-off quick calculations, but now I have this giant lambda call that is many, many characters wide, or this lambda call that's multiple lines, which is also kind of weird and goes against the like something that's supposed to seem quick. So those are like two different bits of friction that might happen while you're trying to create something new for other peoples to interact with. So we did have to go and write bits and refactor and fix stuff such that the way the user can interact with this is you still provide an override dictionary, but you can say, here's the column name. I don't want this filter anymore. Here's the column name. this is the label I want, or I want to override the actual selector, the input component, or I want to change the filter component and also the label. And this lowers the barrier to new people using your tool. And it also sort of just works with how they expect the language to work already. There's nothing new that they have to learn to use your tool. But the cost of this internally, when I first did this with Joe, was we had this two-tiered object initialization phase, which totally goes against any type of object-oriented programming dogma, where you have to initialize the object first, and then there's like a finish in it. And it's like a little hack from the C++ world of how code was written. Since then, I've thought about different ways of making this so we don't actually have to do this. But at the time, this was sort of between Joe and I, this was sort of the trade-off that we did. And so when we were talking about trade-offs, it was, well, there's always a trade-off between convenience for the user, the future developer who might extend your library, your future self, and then like what you learn in school as far as like how coding and best practices go. And at the end of the day, what we decided was if the only trade-off that you're doing is like breaking the rule of what you learned in school, but the user has a really nice way to work with your tool and maintenance becomes easy, then throw away the dogma of like how object-oriented programming works. Like I said, I think there's a better way, and the next update will incorporate a better way. It just means that there's more engineering time involved, and at the end of the day, that's probably always the better trade-off, where your code base might be more complicated, but as long as you reduce the friction for your user, chances are your tool might get used more. So what does the actual final application look like? So by default, it comes with all of the filters already. And the problem before was picking a Thursday or a Friday or a day of the week after lunch. And so now you'll see if I click on lunch, all the other filters adapt to what I've selected. So I can't actually go and pick an empty data frame anymore. And so that's how that's how I was able to add a new feature to Shiny through modules. And, hopefully you've learned some of the things that I've picked up along the way. All right. So with that, slides were on the bottom of the links to the slides were at the bottom of the slides as a footer, but if you need the slides repository, what I've presented is actually coming from a blog post, and so you can actually read the prose form of it as well. And if you want to give Shiny for Python a try, you can totally give it a try. But yeah, I'll go straight into questions. So, what are some of the advantages and disadvantages of writing Shiny apps in Python rather than R? Shiny for I would say there's advantages and disadvantages on both sides. Shiny for R has just been around for a really, really long time. It's been over 10 years, I think. And so it's really hard to change big parts of the language. So the Shiny team has learned a lot over the last 10 years. And some of the things that they wish they can change are sort of just there now, unless they want to backwards compatibility break everything. So Shiny for Python does have the UI is a little bit different. The way you code against it is also a little bit different. In Python world, there's also Shiny Express. So if you're looking for, even less boilerplate code, Shiny Express is also one way you can code in Python as well. How does Shiny compare with other frameworks, libraries such as Streamlit, Dash, Plotly, et cetera, et cetera? One of the things that I would say that it compares well with is you don't need to handle the reactive graph. And I can show you a little bit of the code base, is essentially this part right here, calling filter index, like calling it as a function, that is creating that graph that I showed you earlier. And you can see here in the code base, there's like, other than saying like, hey, this is a reactive call, and like I'm responding to a button click or something, there's nothing in here that is like a callback. It can programmatically find and calculate the reactive graph by telling it it's a reactive calculation, and you're calling it like a function. And so that's one of the main benefits of using Shiny for Python. But all of these other tools are really great too. Like Streamlit makes it so easy to create a dashboard. So it's not that any tool is always, or this is better than all of the other tools, but there's always trade-offs in any tool that you use.
Well, thank you, Daniel. Maybe we can give a round of applause. This is my favorite part. There we go. Awesome. But no, this was fantastic. Thank you so much. We appreciate you presenting, and we appreciate everyone tuning in and joining us. As you know, the videos will be available for replay afterwards. But that wraps up our second day of PyData Global. We hope to see everyone tomorrow again, and have a good evening. Thank you.